So this is the first of several on cellular respiration. And so here, what we want to make sure you understand is what we're talking about here is not breathing. What we're talking about here is actually making ATP, which occurs in the mitochondria. So we're going to spend a lot of time looking at the different parts. So here's animals basically breaking down some kind of food material, breaking that down into eventually what we're going to call glucose for our situation, and making ATP. And so down here on the bottom right is really what we would call the CHO cycle. And you can see we have cellular respiration, photosynthesis, kind of the reverse equations that we talked about earlier. And so we want to kind of look at this in detail and look at where this is happening and how this is happening. So let's kind of take a look at the parts. So that on the bottom is the cellular respiration equation. And I wanted to pop it up there for you. Remember when we did the photosynthesis one, it's actually that in reverse. You remove the ATP on the end, and what you do is where cellular respiration is typed out, you would put in a light and chlorophyll, or at least some type of pigment to collect it. The other thing we talked about last time in photosynthesis, and I just wanted to have it up here, is oxidation reduction. We mentioned it, but here they're showing something being oxidized and reduced. And again, oxidation is the loss of electrons, and reduction is the picking up of electrons. So by definition, so remember we talked about the electron transport chain. That was a series of redox reactions. All right, so just kind of summing up, kind of following through with some of the stuff we did in photosynthesis. So what we want to do is look at cellular respiration. We'll have one more molecule to show you, and that is NADH. You will see actually another one a little bit later, FADH2. And I want you to think of these as kind of coupons, because again, I want you to remember the goal of cellular respiration is to make ATP. But if you take glucose and just let loose, what you see is on the left on the bottom diagram, where you have this explosion of heat and light energy release, but that doesn't help us. So again, we put it into this electron transport chain. And the easiest way to do that is an astable molecule called NADH. And then there's another one called FADH2, which we'll talk about. So these molecules, to me, is kind of like a coupon. Again, we're making ATP. That's our purpose. But we're also going to make these other two molecules, and we'll use them for coupons that we can spend later to make ATP. So hopefully that'll make sense as we go. All right, and then what I want to do is just do the real quick overview, and then we're going to break these down into parts, a little more detail. So depending on who you talk to, cellular respiration has 3 and/or 4 steps. I'm going to break it into 4. The older editions had 3 with this kind of pre-step. Now you're starting to see it kind of broken out into 3.5 steps, I guess. Kind of but I'm still going to call it 4 steps. So I want you to know where they occur. I want you to know kind of the name. The first one we're going to start with is glycolysis. If you look, it's happening in the cytosol. It's outside the mitochondria. And glycolysis, lyse means to burst. Glyco is sugar, break sugars, and it will make some ATP. So again, glycolysis actually occurs outside the mitochondria. The next one is the one I was talking about. That's not necessarily a step per se, but I'm going to call it a step. It used to be called the transition phase, and now they're getting real fancy as pyruvate oxidation. I like the transition phase because it's going from glycolysis to the Krebs cycle, or what's called the citric acid cycle. So there's kind of this mini step, but I'm going to call it a separate step to kind of keep it easier. And what I do want you to know is it occurs as things cross the mitochondrial membranes. All right. The next one is the Krebs cycle or the citric acid cycle. I guess that's the newer name that everybody's starting to use. It's been around, but Krebs is actually the man responsible for coming up with most of the steps in the cycle in the 1930s. All right. So anyway, the citric acid cycle, I want you to know that occurs in the matrix. And then the last one is the electron transport chain and oxidative phosphorylation. And within this is also chemiosmosis. So we're gonna talk about that, kind of try to separate those terms out for you. And so that really kind of happens across the membrane, in the inner membrane, or what's called the little finger-like projections called the cristae. And with that, we'll stop. Move on to the next one.